There are lots of things you might expect to find on the largest object in the asteroid belt, but bright, shiny polka dots are probably not on that list. And yet, there they are, more than 130 perplexingly bright spots on the dwarf planet Ceres. In the months leading up to the Dawn space probe's arrival at Ceres in March, the pictures it sent back got sharper, and we started to see more and more of those spots, but astronomers weren't sure what was causing them. Now, according to a study published in the journal Nature, it looks like we have our answer. The spots are probably made of magnesium sulfate, otherwise known as Epsom salt. We first talked about the mystery of those bright spots a few months ago, and at the time researchers thought that they might be some kind of salt, but they also could just as easily have been some other material that reflects light really well, like water, ice, or certain kinds of clay. So, to figure it out, astronomers looked at exactly how the spots absorb and reflect light. Different compounds have different absorption patterns called spectra, so in theory they just have to match the spectra of the spots to those of the right compound. But of course, it's not so simple. Each spot is actually a combination of different materials, which makes its spectrum a lot harder to analyze. Still, the researchers were able to get a good idea of what might be in the spots by putting some clues together. The spectrum from the middle of the brightest spot seems to be a close match for a hydrated form of magnesium sulfate called hexahydrite, which is just 6 molecules of water bonded to every molecule of the salt. The less bright spots, on the other hand, match better with a version of magnesium sulfate that's only bonded to one water molecule called kieserite. But since all of the spots match with some form of magnesium sulfate, the researchers think they're on the right track. And that tells us a lot about what's hiding inside the dwarf planet, because those spots probably formed when other objects, like smaller asteroids, crashed into it, knocking the dark outer layer off and exposing the bright, salty water ice beneath. Then, sunlight vaporized the water, leaving behind only the salt. Which means that if you were to dig just a tiny bit below the surface, you'd have everything you'd need for a nice, soothing bath, as long as you first melted the ice. So, we're getting closer to understanding the bright spots on another world, but what about the ones in our own sky? The annual Geminids meteor shower is coming up, which means the sky is going to get all kinds of multicolored streaks. Meteor showers happen when something, usually a comet, leaves behind small particles of dust as it orbits the sun. If the Earth happens to cross that orbit, those tiny bits of dust, called meteoroids, can run into our atmosphere and burn up. But the Geminids are unusual because they make up one of the only meteor showers that doesn't come from a comet. Instead, these meteoroids are coming from an asteroid with an orbit that swings close to the sun called 3200 Phaethon. We happened to pass through its trail in mid-December, with this year's peak arriving on the night of December 13th and 14th. And since the moon is setting in the early evening, the sky should be dark enough to get a great view, assuming it isn't cloudy and there isn't too much light pollution. The meteors will look like they're coming from a single point called the radiant point in the constellation Gemini, which is how the shower gets its name. But no matter where you are, you should be able to see the most meteors at around 2 a.m. local time, when Gemini is at its highest point in the sky. Most of the meteors will be white, about a quarter will be yellow, and around 10% of them should be green, blue, or red, all depending on what that piece of dust is made of. If there's a lot of magnesium in it, for example, it'll emit green light as it burns up. The Geminids are also a more recently discovered meteor shower, first reported in 1862, and ever since, the number of meteors each year has been slowly growing. That's probably because the trail of meteoroids is being affected by the gravitation of both Earth and Jupiter, which is shifting it closer to Earth's orbit. As it gets closer, more dust is hitting Earth's atmosphere and burning up. And that shift will continue until the orbit eventually passes right through ours and starts moving away again. So quite soon, the Geminids will start getting less intense, and eventually, probably sometime around 2100, they won't happen at all anymore, so you might as well get a good look while you can. Thanks for watching this episode of SciShow Space News, and thank you especially to our Patreon patrons. Because of you, we are now working on a new soundproof studio, so thank you. Go to patreon.com/scishow if you would like to help out, and don't forget to go to youtube.com/scishow space to subscribe. We're looking forward to not hearing the trucks anymore.